Welcome to Lesson 2, Angle Measures of Triangles. Here we're actually going to formalize with a theorem about how the measures of the angles in a triangle are 180 degrees. I know we've been working with this, but now it's time for us to actually formalize it. So to start off with, the triangle sum theorem. The sum of the measures of a triangle is 180 degrees. So you see in our picture, we have a triangle with angles of x, y, and z, and we know that x plus y plus z is going to equal 180 degrees. So again, this is something we've worked with and we've known, but here we actually are formalizing that idea. Next we have the corollary to the triangle sum theorem. And a corollary is something that can be proven using that theorem. So we can prove this statement using the triangle sum theorem. And that statement is that the acute angles of a right triangle are complementary. See, here we have a right triangle, and we have our right angle, and we know that x and y have to add up to something that will give us 180. Well, that means they have to add up to 90. So this is where we get this statement, x plus y equals 90, and by definition of complementary, this means that x and y are complements of each other. Now this is your first intro to a formalized proof. We are going to be doing some proofs in this unit, and we're going to start off slow by me completing them for you, and then I'll work, and then you'll do some on your own, and then you'll watch the video again and see how you did. So we're going to prove the corollary to the triangle sum theorem. We're going to prove that the measure of angle A plus the measure of angle C equals 90 degrees. We're going to do that using this statement reason proof. Statement reason proof is on the left side. You have all your statements. This is what you say. This is what is. The reason side is you tell why this works, and you have to use theorems. You have to use ideas that are formal. You have to use definitions, theorems, things like that. Now, normally a proof starts off with the given. So that's what number one is. We're saying that triangle ABC is a right triangle. That's given to us. And we're saying that angle B is the right angle. That is also given. We can see that from the picture. So if you can look at the picture and you can see something is there, you can call that a given. Step 2 says that the measure of angle B equals 90 degrees. Now, nowhere in our picture does it specifically state that this is equals 90. But we do know that angle B is a right angle, and we know that all right angles equal 90 degrees, and we know that because of the definition of right angles. So we can state that here. And I don't mind if you use abbreviations in your proofs. So we know that the measure of angle B equals 90 by the definition of right angles. Step 3 says that the measure of angle B plus the measure of angle A plus the measure of angle C equals 180. Well, right there is our triangle sum theorem. That's what our triangle sum theorem says. So that's why we can say that statement. The last statement says that the measure of angle A plus the measure of angle C equals 90 degrees. This is true because, as we stated before, in number 2, B equals 90. So what we basically did was we subtracted 180 by 90, so we moved that measure of angle B, and we're left with this. And this right here states that angle A and angle C are complements of each other. I didn't mean to write that, I just meant to say that. And this is the definition of complementary angles. And there's your first intro to a proof. Most of our proofs aren't going to be any more than 4 or 5 lines. Okay, now here's some examples to use with the triangle sum theorem and the corollary. What you're going to do is you're going to pause the video and solve for either x or y for each example with your group. So go ahead and do that now. Alright, so first we're trying to find x. We know that x is going to equal 180 minus 80 minus 60. So it looks like x equals 40 degrees. We know that y is going to equal 90 minus 30. So y equals 60 degrees. Number 3, y is going to equal 180 minus 85 minus 35. So our y is going to equal 60 degrees again. And 4, we know that x equals 90 minus 45. So x equals 45 degrees. Okay. Now we're going to talk about some more parts of the triangle. Highlighted in blue are the interior angles. The interior angles are the angles on the inside of the triangle. The exterior angles are on the outside of the triangle. Now I'm going to take you back to remember our exterior angles theorem with our polygons. And just think, what are these exterior angles and their corresponding interior angle, what are they going to add up to? What should this angle, and these two angles, what should they all add up to? Go ahead and pause the video and discuss with your group what angle measure they should all be when you add them together. Okay, if you look, you see that they make a straight line after you extend that. We know that straight lines equal 180, so we know that each interior angle and its exterior angle should equal 180 degrees together. Well, this brings us to the exterior angles theorem. It says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Now if we stop and think about that, it makes a little bit of sense, because we know that this angle here, it'll draw, there we go, we know that these two equal 180. Well, we also know that these three equal 180. So if this plus these two equals 180, and this plus that equal 180, shouldn't these two equal that? Yeah, it kind of makes sense when you think about it. So that's where we get this formula, that exterior angle equals the two non-adjacent interior angles. So the two angles that it's not beside. And here we have two examples applying this idea. So I want you to go ahead and pause the video, work through these two with your group now. Okay. So we know that x is going to equal 80 plus 60, so x equals 140 degrees. We know that y is going to be 70 plus 70, which is equal to 140 degrees. Didn't mean for that to happen, but it's act of randomness of numbers. So there's your exterior angles theorem.